7. Okay, so that's y is equal to 1 over x plus square root of cosine. Can you close the door there? Okay, we want to differentiate this. Okay, so Laura, what's the first thing you want to do? Okay, Leo, class has started. Sorry? Okay, what about the 1 over x? X to the minus 1? Write things with exponents because then you can use the power rule. So then this becomes x to the minus 1 plus cosine of x to the 1/2. Okay? So y prime, what's the derivative of x to the minus 1? Nice, good job. Negative 1 times x to the negative 2 plus the derivative of cosine x to the 1/2. So now this is going to be your chain rule stuff. So think of it as if it was a square root of x, x to the 1/2. So what are you going to do first? Hang on, Stephanie. What are you going to do, Laura? So supposing if it was x to the 1/2. Exactly, bring down the 1/2 and then subtract 1 from the half. You get a minus a half. Yes? Times the derivative of cosine of x. Nice, good job. Negative sine x. Okay? So then this becomes negative 1 over x squared minus sine x over 2. What happens to this minus 1/2? You come downstairs because it's negative and you can write it as this. Why is it negative sine x to the 1/2? Okay, remember you got to use the chain rule. So the chain rule is telling you, think of this as if it was an x to the 1/2. So you're going to do 1/2 times x to the 1/2 minus 1, right? Except it's not x, it's cosine of x. So this part here comes out from like here. Then this guy here is going to be the derivative of the inside. This is your inside function right here. That's your inside function. What's the derivative of cosine x? Negative sine x. So you really have to identify the inside and outside functions. That's the one thing you really have to know how to do to be able to use a chain rule. Yeah. Yeah, let me make sure this is all done before we move on. Is this okay? All right, and then the next one was, which one? You had 80?
I didn't get any of them.
Okay, S, which one did you want me to do?
75 and 90.
75 to 90, all of them?
No, 75 and 90.
75 and 90. Okay, well, let's do 75 first then. Okay, number 75. What are they asking? Use a graphing utility to find the derivative. Find an equation of the tangent line. So we're going to do this without a graphing utility. Is that what you're doing?
Yes.
Although it tells you use a graphing utility. You don't want to use a graphing utility to do it?
No.
Why not?
Because I want to learn how to do it.
Do you know how to do it without a calculator? I mean, with a calculator?
I got stuck after the first part.
With the calculator or without the calculator?
Without it. I didn't use calculator for all of this.
Okay. Shall we do it the way it suggests, and then I'll go back and do it analytically as well. Okay, we should have enough time to do both ways. So let's do it graphically first, okay? So what you're going to do is you're going to put this equation in there. So you get 3x squared divided by square root of x squared plus 2x minus 1 okay, does that look okay? And then in order to get the derivative, you're going to go to math number 8 and derive. It's in variable y1 comma the variable that's in y1, which is x, and the x value at which you want the derivative. What's the x value at which you want the derivative? Sorry? Is it negative 1/2 or is it positive 1/2? This is a 1/2. You should have your book open so you know what the hell I'm doing. Okay? And I get like negative 3 point whatever. Okay? So it looks like it's negative 3. So G prime of 1/2 is, what did I say, negative 3? Alright? So that was part A. Find an equation of the tangent line, then you know how to do it from there. Yeah? Got it?
Yes.
So shall we do it analytically then?
Yes.
Okay. So change colors on this. What's the first thing we need to do?
Quotient rule.
You want to use a quotient rule?
Change rule. I don't know. You have to turn both the other.
Yeah, you have to, but you only, okay, let's use a quotient rule. Fine, no problem. Let's do it.
How else will we do it?
You could write this as square root of to the negative 1/2 power and then use the product rule.
Oh.
Yeah, product rule is easier, I think. Yeah.
Okay, sure.
Shall I do this as a product rule then? Write it like this, okay? Write it like this. Okay, now there's a product. There's this guy, and there is this guy here. The two terms that you're multiplying. So we're going to use the product rule.
Yeah, I can probably do it from there.
You sure?
Yeah.
You sure?
The quotient rule, and I didn't know.
Yeah, quotient rule gets ugly
How do you
because
multiply something if it's like that to the negative 1/2 and then there's like another like parentheses or something?
then you got to get the negative 1/2 as a denominator and get a common denominator and all that stuff.
Oh.
Yeah.
Okay.
Loosey goosey. Okay. Is everybody okay with this stuff? Do you want me to go ahead and do this analytically? Yeah, let's do it then. So let's use the product rule, okay? So G prime of t, you're going to keep t squared plus 2t minus 1 to the negative 1/2 constant. Differentiate 3t squared. What do you get when you derive 3t squared? Nice, good job. 6t. We're going to leave this alone. And now we're going to leave 3t squared alone and differentiate this other guy. Anybody? Differentiate the stuff that's on in the black curly thingy.
It becomes 2t plus 2.
No, wait a minute. You're going to use the chain rule now. So think of this as if it was x to the minus 1/2, right? So then it becomes a minus 1/2 comes down here. Okay? This guy gets reduced by 1. So what's negative 1/2 minus 1? Negative 3 over 2 times the derivative of the inside. This is the inside right there. 2t plus 2. Is everybody okay on that? All right? Now you don't need to simplify this, okay, because it's asking you to plug in 1/2 for t. You don't need to, I mean, what's the point of massaging it? Because all you want is the derivative at a point, x equals 1/2 or t equals 1/2. So, why waste your energy doing the algebra in there when it's not needed? Okay? Then just plug 1/2 in there, you'll get a number, and then do the equation of the line. Okay? All right, Laura, which was the other one you wanted me to do? 81? 81 or 90?
Kind of all the same.
Okay, let's do 81 then. Okay, horizontal tangent line. Is that the one? Determine the points in the interval 0 to 2 pi. Yes? Okay, so you've got fx equals 2 cosine x plus sine 2x. Okay? So there's a very simple chain rule application on this one, so it's not too bad. Okay, differentiate. Cosine.
Negative sign.
Nice, good job. Negative sign. Now differentiate sine 2x. Yeah?
So it's cosine 2x times the root of the inside, which is 2x.
Right, so it becomes 2 cosine 2x. Everybody with me on this? This is the same thing that we did yesterday. Laura. Exactly the same thing that we did yesterday.
What's the outside or what's the inside?
So the outside is sine.
The outside is sine, the inside is
2x. No, 2x. So the derivative of the outside, if the outside is sine, the derivative of sine is cosine.
Right.
Right? And then whatever was inside will stay in there. You with me on this?
It's just confusing like
This is the inside. Okay?
Where does the 2 come from?
it's definitely on the other side of cosine 2x times 2.
Mm-hmm.
Then it's with 2 in front.
Yeah, exactly right.
That's the chain rule. Okay, so you know how it's 2x. The derivative.
Now it says horizontal tangent, so f prime should be for horizontal tangent. Remember, derivative is the slope of,
Tangent line.
and if the tangent line is horizontal, what's the slope?
0.
Okay, and then it's a question of solving this. How many ways are there of solving this? Okay, you know your trig identities, then you should be using your trig identities.
Okay, so if it said cosine squared x, what would be the outside?
If it said cosine squared x,
Yeah. The outside would be cosine and then outside.
no, there are really 3 functions here now.
Yeah.
Okay, because there's a cosine. Well, there's a cosine, there's a square, and then there's an x, which would be your inside kind of thing.
Okay, so cosine
So-
squared x would be what?
So cosine squared x would be 2.
On the outside?
Yeah, because it's going to be like an x squared term.
Okay, so squared is the outside function.
That's right.
And cosine is the inside.
Inside, and then inside that is an x. Okay? If you see something like this and you're having a hard time with the chain rule, this is what you need to do.
Because I can never tell what's outside. How come cosine is the outside?
Write it like this. Then it becomes a product rule. Okay? Then it becomes a product rule. So you don't have to worry about chaining 3 times. Okay? Because remember, this is written like this. So the outside is a square. Guys with me on that? Cosine squared x.
The x isn't squared. It's the cosine.
No, it's cosine squared x, right? Is that what you told me?
Yeah, but then
Yeah.
Isn't cosine x?
Hang on, one at a time. Sorry, yes?
Cosine squared x and cosine x squared is different.
That's, yeah, read my notes, okay? Go watch my YouTube.
Yeah, so why did you put it equal to cosine x squared?
These 3 are the same things. Cosine squared x. Well, this is obvious, right? This is algebra 0.
Yeah,
That's obvious.
sure.
The other way is to say that this is equal to cosine x. Remember how this is cosine x times cosine x? Well, what's x times x? Isn't that the same thing as putting a parenthesis around it and doing it?
Oh, so what if it's without the parentheses?
Then it's this.
So what's
That's
the outside?
different.
So then what's the outside?
The outside would be cosine.
That's so
And then, yeah, it is very confusing. I think part of the thing is that you're bringing.
And then cosine 2x is different because of that.
Yes, cosine 2x is not an exponent. Yeah.
Yeah.
What is that?
So it's
Okay, so, sorry?
cosine 2x, cosine's outside. And then cosine x squared, cosine's outside.
Okay, so now we are into trig and trying to solve this equation. We are into trig and trying to solve this equation. Okay? So what I would suggest to you is get your identity sheets out and find out an identity for cosine 2x. And then it's a question of, and there are 3 identities for cosine 2x, okay? There are 3 of them. It's a question of using the correct one. Sorry? Sorry, I can't hear you. Because it's a slope of the tangent line, which is horizontal. What's the slope of a horizontal line? 0. Okay?
But that's the slope of it?
Yeah, right here. Here, this is the derivative. Isn't the derivative the slope of a tangent line?
Oh.
And the tangent line is horizontal, so the slope is 0. Okay, you guys looking at your identity sheets there?